Hello everyone, welcome to the Intro to Nim for the uninitiated talk. My name is Dominik and I will be presenting today. I believe this is the first talk for the Nim conference, so welcome and let's get started. I hope you will enjoy this. So, what is this talk? Nim is an emerging language, and because of this, I wanted the Nim conference to have a talk introducing Nim to the vast majority of developers. It's important for us as a community to be aware that most developers have likely never heard of Nim, and so we need to start from the fundamentals when talking about it. This talk's content is split into around a third, talking about what Nim is, and in general getting you, the viewer, excited about learning it. The rest 2/3 will be spent teaching the basics of Nim. So, who am I? My name is Dominik Picheta. I am a core developer of the Nim programming language. I wrote the first Nim book and implemented various Nim tools and libraries, including the Nimble Package Manager and the Jester Web Framework. These days, I have less time to work on Nim projects as I am working full-time as a production engineer at Facebook London, but I do still love Nim and really want to see its adoption grow. So what is Nim? Almost a year ago now, Nim 1.0 was released, and with that release, Nim has reached a level of maturity that very few emerging languages reach. These 1.0 releases are very important because they establish a solid foundation of a language. It means that software projects do not need to worry about their code being broken in the future. And it is really an invitation to begin using Nim for serious projects in production. On the surface, Nim is a programming language that is statically typed, compiled, easy to learn, and productive to work in. It is also garbage collected. In my eyes, and this is a little subjective, Nim truly brings together the efficiency of C and the productivity of Python. Now, I can list features all day long, but that's not the best way to get a sense of what a programming language is. One other way is to learn a bit more about the language. But another good way is to learn how it compares to other languages. This is particularly useful if you are familiar with the language that we are comparing against. So I will pick up a few of the most popular programming languages and talk about how Nim stands out. So let's get started with C. It is the most popular language according to the TIOBE index. Even if you have never used it, you likely have a general intuition about it. You likely view it as an efficient but unsafe programming language. A language that will give you a dependency-free binary, but which requires a lot of effort to write bug-free code, especially when it comes to memory safety. C is tough to escape. Most mature and well-written libraries are written in it. This makes interfacing with C via the Foreign Function Interface, or FFI, very important, which is why most languages readily support it. Most operating system APIs also expose a C FFI, so it's very important to support it. Nim is perhaps closer to C than most, as its only complete implementation actually emits C code. This makes Nim's semantics similar to C's in some ways, and enables interfacing with C libraries to be incredibly easy. It also means that Nim can take advantage of the many decades worth of optimizations made to various C compilers. And indeed, Nim supports everything from GCC to Intel's C compiler. So to recap, C is Nim's cousin. Nim adopts C's performance and its massive collection of mature and brilliant libraries. So how about we compare Nim to Java? Java is a very different beast to C. For one, it doesn't compile to native code, but instead relies on the Java virtual machine. This is a heavy dependency which I have personally always sought to avoid. Java is also garbage collected and has many limitations, which mean it cannot be considered a systems programming language. Nim itself is garbage collected by default, but due to its proximity to C, allows you to truly get down into the low-level details if you really want to. You can manipulate pointers, you can even write kernel modules directly in Nim if you really want to. Java does not make this easy. Java is also incredibly reliant on reference types. Every object you use is allocated on the heap. Not giving the programmer the ability to use value types allocated on the stack is a huge downside. Nim has a very clear separation between value and reference types, allowing you to choose which is more appropriate for your program. So to recap, while Nim is garbage collected, the garbage collector can be turned off. Nim itself is a systems programming language, offering many of the features often seen for those kinds of languages, including value types and the ability to handle raw memory manually. Comparing Nim to Python. When I first found Nim, I was actually searching for alternatives to the Python programming language. By default, Python is not compiled nor statically typed. But I love Python to this day. Even though its reliance on the slow Python interpreter with its global interpreter lock has always had me searching for alternatives. Furthermore, Python programs are only just recovering from the Python 3 release, and there are still popular libraries that do not support Python 3. This is a much bigger issue due to Python not being compiled. I consider Nim to be syntactically very similar to Python, but there are also many features like iterators which have been heavily inspired by it. This similarity is what caused me to pick it up. To this day, I strongly believe that every Python programmer should give Nim a try. You can truly be as productive in Nim as you are in Python, but the benefits you gain are incredible. Nim gives you much greater performance, true parallelism, and static typing, which does not get in your way. You also get a dependency-free binary at the end of the compilation process. The only sacrifice, if you can even call it that, is Nim's discouragement of object-oriented programming. Nim is a procedural language, and that is a bit of a paradigm shift, but not a large one. Comparing Nim to Go. It may surprise some to learn, but Nim is actually older than Go. Google is a huge force behind Go, and I would say that is one of its biggest strengths. But I dare say it is also one of its biggest weaknesses. Google is infamous for shutting down great projects, even if they have a large number of users. See Google Reader as a great example. It is also tough to get involved in contributing to a large language owned by a big, multi-billion-dollar company. I personally started contributing to Nim when I was 14, which shows how open Nim development really was and continues to be. I personally consider Go to probably be one of the closest languages to Nim in terms of their basic premise. Both are statically typed, fast, and compiled programming languages. Even Nim itself was founded on a goal of simplicity, a small core that is to be extended via its strong metaprogramming features. But Go goes a few steps further towards simplicity. And I would say that it goes a few steps too far. Go lacks both generics and exceptions, which Nim offers in a much more flexible package. And unlike Go, Nim can actually be considered a systems programming language. Ultimately, Nim gives the programmer more power, but retains some of that simplicity that Go is known for. And I think it strikes a much better balance than Go has ever done. Now that I've talked a lot about Nim and other languages, let's move on to the teaching section of this talk. I hope this will work as a good introduction to Nim for existing programmers, but it will by no means be exhaustive, in fact, far from it. The easiest way to try out Nim is using our playground, which is available online at play.nim-lang.org. I encourage you to follow along with the examples I will be presenting in this section via this playground. You can, of course, also install Nim just like any other language. The Nim distribution includes the Nim compiler, Nimble package manager, and various other tools that make Nim development easier. The easiest way to install Nim is through your system package manager, think Homebrew or Aptitude, or you can turn to the Choose Nim tool, which allows you to install practically any version of Nim and handles switching between them for you. If you want to learn more, simply go to the Nim install page from the main website. So, let's get started with the fundamentals. Here is how you show messages on standard out. This is the classic Hello World example. And you see that it's fairly simple. We simply call the echo function and we pass it a string, and it makes its way to the standard output. The beauty of Nim is that you do not need any special directory setup to compile this. If you're using the playground, you can just simply copy and paste it in there and click run. If you are following along on your local machine, you can just save this one-line statement into a file and then run nim-c-r and the file name. There's no need for any special directory setup or anything like that. And yeah, when running this command, you will see lots of compilation output, and finally the executable will run and show you the hello world message. The nice thing about the echo statement or procedure is that it accepts any type which has a toString operator defined on it. The toString operator in Nim is simply the $. And in Nim, most types have one defined, so you can echo just about anything. In this case, we are echoing an integer, a float, and also a very useful type called the option, which is just a container for any type of data. It allows you to model a function, for example, returning nothing or a specific value, which is very useful when programming. And most modern languages support this. You can also see here an example of modules. We are importing the options module, which contains the definition of the option type, and in particular the sum function, which we call to construct the option type with a value of 42 inside it. The output here looks like this. I believe it's fairly self-explanatory. You basically get the 42, the 1.42, and the string representation of the option structure, which in this case is sum with a 42 inside it. Now, just to hammer home the toString operator, when you're calling echo, what you're actually getting implicitly is a call to this function, as you can see here. The dollar is actually a function call to the dollar operator. So if your type doesn't have that function defined, echo will not know what to do with it, and it'll complain at compile time. One other thing to mention about the modules is that in Nim, when you import a module, any functions or types that are exposed by that module end up being able to be accessed without prefixing with that module name. So in the case of the options.sum function, we can just write sum instead of writing options.sum, like we might need to do in Python, for example. There is a way to get the same behavior as Python by simply writing from options import nil, which will force you to prefix each function call from that module with options. But this isn't the convention used in Nim. You've got to remember that Nim is a compiled and statically typed language, so problems to do with collisions are rare, and when they happen, it's very easy to fix them. Let's turn our attention to variables. Variables can take many forms in Nim. Defining them is practically identical to JavaScript. You can see in the example we are defining a sentence variable, which is set to nim is basic string literal. And in this case, sentence is a mutable variable, which is signified by the var keyword. This means that we can very easily change it. We can add extra string literals to it. In this case, we are adding the string containing space followed by the word awesome to create nim is awesome. Those variables that are defined using the let keyword, as you can see at the bottom of this example, are immutable. You can only assign a single value to them. You cannot change them later on. And if you try to compile this example, you will see an error message on the last line because age is in fact immutable. All variables in Nim have a type, but the Nim compiler is very good at inferring them in most cases. So you can save a lot of valuable keystrokes. You do not need to say that the sentence has a type of string. Nim knows about it from the string literal that you assign to it. Nim also supports constant data. And the neat thing about this is that Nim can actually compute this data at compile time for you. In the case of this example, we have an unknown fib function defined somewhere that we are calling. And this function will be a simple implementation for getting the nth Fibonacci sequence. Now, this may take a very long time to compute, and maybe you do not want to compute this at runtime. So what you do is you ask the compiler to do it for you when compiling. This may increase the compile time, but that may be a trade-off that you're willing to do. In that case, the Nim compiler will compute it and simply embed it into the resulting executable. So the resulting application will simply have the result embedded in it, which will be 832040. or the 30th Fibonacci number. Now, of course, there are some limitations here. Most functions, however, can be executed at compile time by the compiler. And that's a very powerful feature. Just to give you some sense of what control flow structures look like in Nim, here's an example of an if statement in a for loop. As a bonus, I am also showing the string formatting features which live in the strif format module. The syntax overall is very similar to Python. We loop from 1 to 10 at the beginning, using the I as the iteration variable. And then we check whether I is even by using the modulus operator. And finally, we display a message if it is. The FMT syntax is defined in the strif format module. And it means we can perform string interpolation, as you can see in that example, where we effectively embed the I iteration variable into the string. And this will print effectively 2 is even, 4 is even, 6 is even, and so on until 10. Feel free to run this in the playground or otherwise. So let's turn our attention to procedures and functions. How do we define functions in Nim? Well, Nim actually has two names for these, procedures and functions. The example given here will compile and when run, ask you for your username. The syntax is fairly simple, with the proc keyword being followed by the name of the procedure, followed by the return type, which in this case is a string. We then write to the standard out. The reason that we don't use echo here is because we don't want the new line being written. We just write your username and we don't start a new line. This means that the user can type in their username on the same line and it feels more natural. We then call the readLine procedure on the standard in, which is globally available. As you might imagine, this reads a line from the standard input. So when a user types in their username and presses enter, we get the result. This also shows a very special feature of Nim in that all procedures with a return type have a result variable. And this result variable is implicitly defined and implicitly returned. So in this case, we are simply assigning it. And this is effectively the same as writing var result equals standard in.readLine followed by return result in more traditional programming languages. The rest of the example is fairly self-explanatory. We just call the getUsername function, assign its result to the username variable, and then we display it. One aspect that this shows is that the echo statement can actually take multiple variables or string literals to be shown, similar to the print statement in Python. Now we look at functions. This is the same example. The only difference is that we've replaced the proc keyword with the func keyword. And this causes the compiler to fail with an error. This is because functions in Nim are effectively procedures that are side effect free. And because standard.write and standard.readline have side effects, it means that we get an error about that. As you might expect, procedures and functions can take arguments. Each argument has a name and a type. In this example, both arguments have the integer type, with the return type being an integer as well. We have an add procedure which takes an x and a y argument, both of an int type and an int return type, and then we return those two variables added together. Procedures in Nim are by default not visible outside their module. In other words, they are private, they have a private visibility. The way that we make these public is by using the asterisk just after the identifier of the procedure, as can be seen here. Simply in between the parentheses and the name, and this makes the procedure exported. Procedures and function argument types can also be made generic. Our previous add procedure only worked on integers, but this can work on any type that implements the plus operator. In this example, we define a generic type t, and then we use it for both the arguments to this function as well as the return type. Calling this function can be done with basically any numeric type. As long as that type has the plus operator defined for it, it'll work. Nim has a very wide array of data structures, but one of the most commonly used is the good old sequence. This is effectively a list or an array that can be grown at will. In this example, we define a names variable, which is a sequence containing strings. We then add the name Mike, John, and Peter to it, and then we display it using the echo statement. And the output here is as shown. Sequences can only store a single type of value. As in this case, a string. You cannot add an integer to this sequence. Sequence literals are defined using the @ symbol followed by square brackets, as you see by the output. Another useful data structure are hash maps. In Nim, they are supported for the table type, which needs to be imported from the tables module. You can see that in this example, we are importing the tables module, and then we are defining a years of birth variable of type table containing keys of type string and values of type int. Tables in general take just two types, the key type and the value type, and then they store a mapping between the key and the value. You can also construct tables using a similar syntax to the one shown at the bottom in the output. More information and examples can be found in the documentation for the tables module. This is a bit of a longer example, but I feel it's important to learn about these three things. Here, what I am showing are how to define custom types in Nim. And custom types in Nim are defined under a type section. You can see at the top of this example is where we define the type section with the type keyword. There are effectively 3 different data structures that can be defined. Tuples, which you see at the top, objects in the middle, and reference objects. That's the last state object that we define. Tuples only care about the order of types. They do not care about their names. They can have field names associated with them, but they don't always. And that is not a requirement. You can see that I am creating a tuple with no field names when I am creating the item variable around the middle of the example. Objects, on the other hand, need field names, and you need to specify them when they are constructed. Object construction is done by using the name of the type followed by a list of field value pairs. You can see that I am defining the person object, or an instance of it rather, with the name set to Adam and the age set to 12. Non-reference objects are value types, and as such are allocated on the stack, whereas reference objects, or ref object, are allocated on the heap and collected by the garbage collector. Reference objects are also unique in the sense that they can be modified. This may look surprising because state variable is defined as a let. But because it is a reference type, the underlying data can actually be modified. It's just that the reference cannot be changed. You can also see how to access fields in that last line. It's fairly similar to other languages, where we use the dot to access different fields. In this case, we are actually accessing the state.people, the people field in the state object. And then we call the add function on it. Tuple fields, on the other hand, can be accessed by either the field name or an index. The tuple that we defined for item is unnamed, so we have to access it using the indexing operator, which we do by using square brackets with a 1. So this is pretty much all I'm going to cover. This is, of course, mostly the fundamentals, but I hope it gives you a sense of what nim looks like and hopefully encourages you to learn more. The only thing left for me to leave you with is to teach you how to take it from here. It's especially important to be aware of how the nim standard library documentation is structured. Each module has its own page, with all the types and procedures that are exported listed. If you are looking for a listing of all the standard library modules, you can find that on the first link in this slide. If you are looking for a specific procedure name, you can use the integrated search box on each page, or if that fails, which it might as the search isn't quite perfect yet, you can have a look at the documentation index page, which lists all the modules, procedures, types, and everything else that is exported by all the modules in the standard library. That's the second link in this slide. When going on this page, simply use your browser's search functionality, usually available by pressing Ctrl F or Command F on Macs. If you want to learn more, there are many resources out there, tutorials, how-tos, and other videos, and of course my Nim book, Nim in Action, which is still very much relevant and supports Nim 1.0 and above, You can find more information about it on the third link in this slide. And that's it from me. Thank you very much for listening. Happy to answer any questions. I am probably been answering questions throughout this talk while it was streaming. But if you have any other questions, please feel free to contact me on Twitter. I am, my handle is D0M96. That's Dom96 with the O replaced by a 0. Feel free to follow me as well on Twitter if you wish. I am also Dom96 on most other social media and IRC, Discord, Telegram, and things like that. And if you're interested in Nim, be sure to also follow nim_lang to get news about Nim and all the awesome stuff that the Nim community is working on. So I will leave you with this. Thank you for watching and have a good rest of NimConf. Thank you.